Hello, Fraction Camp, fraction routine using pattern blocks. This is addition of fractions part 2. So I've established one whole right here, and I want to know what is the value of these two red trapezoids combined. On the side, you want kids to be able to say, well, the value of this block is equal to 1/5, and then you want them to give some reasoning. That's 1/5, by the way. You want them to give some reasoning, and their reasoning should be, oh, there's 2, 4, 5 red blocks that are equivalent to the whole, so that's 1/5. And there's 2 of those blocks here, so that's 2/5. You want them to give some reasoning. The reasoning is 2 blocks, each with a value of 1/5, has a value of 2/5 combined. So this one might be a little more of a challenge. So I'd start with this one and say, recognize that there's 4 brown blocks in each, 4 brown trapezoids in each of the yellow hexagons. So that's 4, 8, and then there's 2 brown blocks in the red trapezoid. So that's 1/10. And my reasoning is because there's 10 equal size blocks that make up the whole. And notice that right here, this is now going to be equal to 3/10. And I want to give the reasoning. Remember, 2 brown blocks make up a red block. And now what I want to know is, what is the sum of 2/5 plus 3/10? So to do that, I'm going to have to build a model. I want to build this model so that it looks like this. So that it looks like the sum that I have here. And what is that? That's right. I think, remember now, that's the equivalent to that. And here I have another equivalent, building another, let's see there. So looks something like this. So now what I have is 4/10 plus 3/10, and that's equal to 7/10. And that's what the answer is, 7/10. Remember, if you are a teacher who has already taught an algorithm for this, then when you teach kids to do 2/5 plus 3/10, then it might look something like this. You would say, oh, I have to find a common denominator. And so you might say 5, 10, 15, 20, like that. And then you might say 10, 20, 30. And you tell the kids to circle the first time they have a common multiple. You'll call that least common multiple. And then you'll convert. So this one doesn't need to be converted, but that one does. So it's 2 times. So you would then teach the kids to do 2/5 multiplied times 2/2. And that gives you 4/10. And that one's already 3/10. And then you get 7/10. Nothing wrong with that. Well, there is something wrong with that if you're 8, 9, or 10 years old. And the problem with this, and I'll call this, I'll put it in blue and say it's highly abstract. What I mean by highly abstract is you're probably only going to understand it if you already understand fractions, which they don't. So this is a way to build understanding. And instead of saying they have to have a common denominator, say I can only add the same color blocks. And as you can see, when I am only adding the same color blocks, what I'm doing is finding a common denominator. Later, once you've established this conceptual understanding, you can add this chunk to it and say, can you see that it's the same thing? This is a way to strengthen the conceptual understanding of fractions that your 8, 9, and 10-year-olds are going to need to understand to be able to move forward in their math, and also to make them more confident in their understanding. Most of the time, for most students, when they are taught this way, they really walk away saying, I did all the tricks my teacher taught me, but I kind of don't really know why. And then if they're presented with a problem that is different than the structure of the problem their teachers have taught them, then they cannot do it. They can't transfer their knowledge to a more complex or even a similar complexity with a different structure. So this kind of work takes longer, but it leads to deeper understanding. And I'm going to argue that if you've done what I have suggested that you do, then this is going to actually save you time in the long run.